Greetings, students. Mr. Keister here with you again. Today, this is the video for, let me double check. There we go. Wednesday, August 12th, which is our scheduled second day of school for the fall semester. So let me refer then to our schedule today, which I call the do nows on the board behind me. So today, if you're in class, or if you were in class, you would have picked up 4 papers today, pages 7, 8, and 9. Remember, those papers will be laying across the front of my desk here as you enter the room. Our lab equipment study sheet, our lab equipment worksheet, our lab equipment names and definitions. So it looks like we're going to be talking about lab equipment at some point soon. And then I have a little star here by this one. These are the registration instructions for Mastering Chemistry, which is our online homework a place that we use that is provided by our textbook company, Pearson. You will have an online homework assignment in every unit that we cover. Once or twice, there might be 2 online assignments with each unit. But a great majority of the homework that you do in this class will be paper and pencil homework. This is a supplement to that. I like Mastering Chemistry because it gives you some good practice for when you go off to college, because a lot of your homework in college is online. Very, very similar. In fact, I know the online curriculum that they use at Purdue is very, very similar to Mastering Chemistry. And so this just kind of gets you in the mode of doing online homework, because it is much more prevalent as we delve into the future. It's becoming a more and more prevalent type of homework that is given, especially in college. So we will not go over those instructions now. When you're in school, you will, of course, pick that up, and I will go over it then. If by chance we remain out of school for an extended period due to COVID-19, then I will at some point here in the not too distant future go over those instructions with you, excuse me, when I have them ready. Those update each year, and so I might need to make a change or 2 to the instructions. So anyway, from yesterday, which was our first day of school, these were all the papers we picked up yesterday. I reminded you about the seating chart that we were to follow the entire first semester. And this is the normal way that I will have things listed on the board every day on the schedule. Your homework for today was to complete the day 1 lab over chemical reaction rates. We'll go over it quickly, and then you will turn that in for grade. So I will go over that here. We talked quite a bit about it yesterday, the day that the lab was completed, and you would turn that in then before the bell, as I talked about in yesterday's video, so that it is not late. Today that'll be a little different, because we're going to go over it first before I have you turn it in. Normally you would turn in your homework prior to the tardy bell. Normally I have the answer key posted on the backboard by 7 a.m. of the day it's due. I mentioned that the other day, which allows you to check your work. I always encourage you to do that. Then when the bell rings, your homework should already be on my desk. So like I said, today is a little different because we're going to go over it first before you turn it in. Also, you were to complete the laboratory safety study sheet as homework for today. Hang on to that. I'm not going to have you turn it in. We're going to go over it quickly, though, in class, and then I'll post the answers for that on the board as well. Again, if we are out of school and learning remotely due to COVID-19 or any other circumstances, since you wouldn't be able to check with the answer key here at school, I will put that answer key on my Canvas homepage so that you can check it from your computer. So don't ever worry about that. Okay? If you have questions over anything, be sure to let me know. we're in school, of course, you can ask me directly or shoot me an email anytime during the school day. If you're at home, you can shoot me an email as well, and I will answer. Okay. I talked about getting registered in Mastering Chemistry again. When we come to that point in time, I will address that with you separately. So let me run to my desktop here, which is where I run the screen. Advance that. Again, I videotape from my laptop and run the screen from my desktop. So today in class, we'll discuss as a class the lab results up on the front board, and then you'll, like I said, turn your lab in for a grade. We'll go over the lab safety study sheet. There will be a quiz over that in Canvas, multiple choice format. That is scheduled for this coming Monday, with today being Wednesday the 12th. Then that quiz would be scheduled for Monday, August 17th. Okay, and we would be taking that during class. The other thing that we were going to do today, I was going to have you go back in the lab area and rotate through the lab equipment so that you could see what it likes in live real time. Now, obviously, since we're here doing a video, you are not able to do that. You can look at the pictures of each of the pieces of equipment. Some of them you'll be familiar with already, maybe quite a few of them. You'll be able to look at the pictures of them, and then tomorrow, on tomorrow's video, we will have a practice lab quiz where I will show you each piece of equipment, and so that you can get a better look at what it looks like really. Now, hopefully this won't mess up too badly. I'm going to actually unplug here and real quick. Oh boy, we'll see if this works. We're going to walk back to the lab area, and I'll show you how that setup is. So hopefully, let's see, hopefully you can see that. Here we go. So basically what I have here is I have all the pieces of lab equipment set up in order that I was going to present them. And you were going to walk through the room. And I know I'm doing this kind of quickly, but just to give you an idea. You're going to walk and rotate your way through the lab tables so that you could see everything in real time, just like so. And then as you were doing that, you were going to write down, again, in order, the name of each piece of equipment and what it's used for. Over here, I don't know if you can see that, I have a paper sitting on the table right there that talks about questions 25 and 26. And again, on your paper today. And I'll go over that with you tomorrow when we do the practice quiz. So that was kind of how it was set up in class. So let me get back up here at my desk. There we go. That. There. I think that'll work. Okay. So I think that takes care of what we're going to do today. So first things first, we'll look at the lab results from yesterday. So let me go pull that up. There it is. So again, and we talked about this yesterday, if we're here in school and you actually performed this lab yesterday, then you would have your own data written up here for your reaction times. If we are by chance not in school, I wrote some numbers down up here yesterday that were the average of the class data from last year. And then we talked a little bit about the questions I was going to have you look at and contemplate between yesterday and today, and let's talk about those now. So question number 1 here under conclusion wants us to discuss, or wanted you to discuss your results with your lab partners to write a conclusion that states the specific relationship between reaction rate and temperature. We talked about this yesterday, that as the temperature of the particles is increased, those particles have more energy and thus are moving faster. If they're moving faster, then they're going to collide and react with one another quicker. So, some statement that you would make would be something to this effect: the higher the temperature, the faster the reaction rate. Or conversely, the lower the temperature, the slower the reaction rate. Second question asks, what's the relationship between reaction rate and concentration of reactant? Remember in one of the experiments, I think it was the last one, we diluted solution B with water. And so although we had 20 mLs like we did in all the other experiments, in this particular one, we only actually had 10 mLs of solution B, and the other 10 mLs was distilled water. And so the quantity of particles of B was then cut in half. So the concentration was less. So, and we saw that that time was quite a bit slower. So the relationship there would be then that the higher the concentration of the reactants, the faster the reaction rate. More particles means more collisions, more reaction, and thus a quicker pace for that reaction. And then, or conversely, the lower the concentration of the reactant, which is what we actually did, the slower the reaction rate. And then under analysis, question 1, why then? These are the whys. Why does reaction rate increase with an increase in temperature? And we mentioned this already. At a higher temperature, the particles move faster and collide, since they have more energy, and collide more, which then increases the speed of the reaction. Number 2, why does reaction rate increase with an increase in concentration? Well, here again, at a higher concentration, you have more particles in a given volume. You have more particles, you increase the collision rate, and so once that occurs, the speed of the reaction then, of course, is going to go up. So at a higher concentration, there are more particles, so they collide more, which would increase the rate, or conversely, at a lower concentration, there are fewer particles, so they would collide less often, and the reaction rate would then go down. So, again, if we're in school, we would be able to check that, check your work, make sure you have everything down that you need to before you turn the paper in. If by chance we're not in school, I will have this sent to you through my Canvas homepage so that you can check your work. So that takes care of that. Okay. Next thing on the agenda today was I had you work on your lab safety study sheet as homework for today, and we're going to go over that real quickly. And again, if you missed something, of course, you can always stop the video and go back and look at it again, make sure you got what you were supposed to get. And also, I will, again, you would have been able to check this answer key in class as well on the board in the back. Oh, by the way, I didn't show you that board, so let me put this up. You won't be able to see it. Oh, well, maybe you can. There we go. Back there in the lab area, you see those two big whiteboards in the back. Well, it's actually one large one, but I have it split into two sections. The section on the left is for Honors Chem. That's where I post the answer keys there. And the section of that board to the right is for Chem 2. I post their answer keys there. So that's where you would check those if you're here. And but like I said, if we're not here for whatever reason, then I would send those to you, the links to those documents to you through Canvas. So anyway, so we're going to go through these very quickly. I think a lot of these, as I mentioned yesterday, are pretty much common sense. You probably already would have been able to, I would think, reasonably answer most of these questions correctly on your own without any looking up anything else. But there might have been a few that have tripped you up. So, question 1 said, to extinguish a lab fire, you should know how to operate a fire extinguisher. Where are the extinguishers located? Who is responsible for using it? And all of those things. D, and the correct answer, of course, is D, all of those. We have 2 fire extinguishers in our room. One, hopefully you can see that, is back there in the back in the lab area. I have a second one up here towards the entrance to the room. Those, if you're familiar with fire extinguishers, there's a pin at the top that you have to pull. Otherwise, you can't depress the handle at the top. So you pull the pin. You always aim the extinguisher at the base or source of a fire, never at the top or in the middle, at the base, and you depress the handle and away you go. In 25 years of teaching, well, this is year 25, I have never had to use a fire extinguisher in class, and I certainly don't intend to use one now. So anyway, question 2, flammable materials like alcohol should never be dispensed or used near B, an open flame. That's the correct answer, B, an open flame. Question 3, if a laboratory fire erupts, notify your instructor at once, and then, correct answer is A, follow the science instructor's directions. Question 4, approved eye protection devices like goggles are used in the laboratory. D, anytime chemicals, heat, or glassware are used. Even if we're just dealing with the graduated cylinder and water, we wear goggles, all right? It's mandatory because anybody could drop a graduated cylinder or another piece of glassware, and it could, when it hits the table, it could bounce up and hit you in the eye. Heaven forbid that would happen. But we can never be too careful with eye protection, so that's something that I'm a real stickler on. Question 5, if you wear eye contact lenses in the school lab, the correct answer is C, advise your science instructor that you wear them. The reason being is if by chance, somehow, you get some type of chemical in your eye, contact lenses kind of act like a sponge. That's how they work. That's how they adhere to your eye from the moisture in your eye. That liquid that would be introduced in your eye would just literally get sucked under your lens. And so it's important to know that. By the way, let me lift this up again. See it right there. You see next to my big periodic table there is the yellow safety shower, and which is at the top, and then beneath it is the eye wash station. So if by chance we do get anything in our eyes, we would go over there and turn the valve on, and you basically stick your face right down in there and flush the eye out. So, funny story about that shower. I don't know if you can see over there. If you can see it, there's kind of looks like a triangle hanging underneath the yellow sign there. This would have been, I don't know, 2-3 years ago, maybe a little longer than that. I had a kid walk by there in the first period, actually, and he was had his book bag, slung around his shoulder. And when he walked past the shower, somehow, I don't know how it happened, his book bag caught that yellow triangle and it got stuck in there. And as he walked on past, it jerked the triangle down and the shower came on. Well, let me tell you, we scattered quickly because that water comes out really fast. And I don't know if you noticed or not, but there's no floor drain over there. And so the water just spread throughout the entire room very, very quickly. By the time I ran over there and got the thing shut off, we had quite the mess. And in fact, it took about 20 minutes of period 1 to get all that water cleaned up. Of course, people's book bags were on the floor and whatnot, and everything. Oh, it was a mess. So anyway, I know the shower works. I've never had to use it, thankfully, but we know it works. So anyway, that's where it is. Back to the study sheet. Number 6, if you develop a headache in the lab, you should B, tell the instructor. I, of course, would then write you a pass to the nurse if it's bothering you enough, and let you go take care of that. Next page. Question 7. Question 7. If you do not understand a direction or part of a lab procedure, you should C, ask the instructor before proceeding. That's what I'm here for. answer any of your questions so you don't proceed doing the wrong thing. Question 8, after completing an experiment, all chemical waste should be, B is the correct answer, disposed of according to your instructor's directions. Some things can certainly be dumped in the sink. Some things could be dumped in the trash, but not always. A lot of times I will have a waste container available for you to take care of particular types of chemical waste, which then our safety guru here in the science department, who is Mr. Powell, will take care of it at a later time. Let's see, number 9. If the lab experiment is not completed, you should A, schedule a time with your instructor when you can complete it. I kind of like letter D. That's kind of funny. Make up some results. I'm sure that's happened, but it's not the right thing to do. Normally, we have enough time to complete our labs within the period allowed. If by chance that doesn't happen for you or your group, on occasion I have scheduled a quick time during their lunch period or after school or whatever, early the next morning before first period, whatever, to get it done. Let's see. Where are we? Number 10. Spilled acid should be neutralized with, keyword there is neutralized. The correct answer is D, sodium bicarbonate solution. All right, so that's basically sodium bicarbonate is a base. We neutralize, again, that's the key word, we neutralize an acid with a base so as to negate the negative effects of that acid on whatever. We have a similar question to this one coming, but that talks about spilling an acid on a person. This is basically like if you spill it on the table or the floor or whatever. 11, you're heating a substance in a test tube. Always point the open end of the tube, D, towards no other person. All right. We'll talk about that when we look at the Bunsen burner and heating and so forth here in a couple of days. Number 12, you're heating a piece of glass and now want to pick it up. You should C, wait until it cools. Newsflash, hot glass and cold glass look alike. You really can't tell the difference. Perhaps this has happened to you at home, and so hopefully not. But anyway, glass has a pretty low specific heat capacity, which means its ability to hold heat is not all that great, which means glass heats up very quickly and it also cools down fairly quickly. So just give it a little time and wait and then pick it up. 12. You're heating a piece of glass and now want to pick it up. So you should A, use a rag or paper towel. B, pick up the end that looks cooler. Well, we just said you're not going to be able to tell what end that is. C, wait until it cools, which is what we just said. So the answer there is C. The answer to 11 was D. 12 is C. 13, you've been injured in the lab, cut, burn, etc. You should first tell the instructor. All right? Let me know, and I'll take it from there. Next page. (14) When gathering glassware and equipment for an experiment, you should, all of those, read the directions and know what equipment is necessary, examine the glassware to check for chips or cracks, clean any glassware that appears dirty. The answer to that is D, all of those. 15, pipettes are used to measure and dispense small amounts of liquid. Pipettes are back in the lab area there, one of the pieces of equipment you'll be looking at here later today. And anyway, you should draw the liquid into the pipette by using your mouth. No. Any of you that ever siphon gas with a rubber hose, no, you're not to do that. B, a rubber suction bulb. C, a pipette pump. Or D, B, or C. The correct answer there is D. Most pipettes, including the ones we use, have a rubber suction bulb on them. You squeeze the bulb You insert the pipette in the squeeze the bulb, insert the pipette in the liquid, and then release the bulb, and that draws the change in pressure, draws the liquid up into the pipette. Those are the kinds we use. Now, if you're using a much larger pipette, it becomes much more difficult to get the pressure changed enough to draw it in there, at least very much. And so that's what a pipette pump is used for very large pipettes. We don't really have a need for those here. But the correct answer is D. Okay. 16. You want to place a piece of glass tubing into a rubber stopper after it has been fire polished and cooled. This is best done by D. All of those. All right, all of those. 17. Eyeglasses provide as much protection as none of those. All right, glasses are not good enough in the lab to protect your eyes. 18. Some alcohol has been spilled. What is the best cleanup procedure? Correct answer there is B. Tell the instructor. Now, some of you might have said let it evaporate or clean it up at once. Maybe in some cases, maybe in most cases, that either one of those would work. But not all alcohols are the same, and some have much more damaging effects to the skin than others do. And so best idea is to be safe about that and just let me know and I'll take care of it. So the correct answer there was B. 19. Paper towels or rags with flammable liquids or solid chemicals on them must be put in a designated chemical waste container. Again, we don't want to cross-contaminate anything else. And so when that comes up in the lab, I'll let you know where that container is. Number 20, long hair in the laboratory must be A, cut short. No, don't have to cut it. Although I don't have to deal with that, obviously. Back in the day, I would have. But anyway, the correct answer there is D, tied back or kept entirely out of the way with a hairband, et cetera, et cetera. And even when your hair is tied back, I wouldn't be bending over leaning your head over the Bunsen burner when you're using it. Any of you ever been around that, you would know that there's not a whole lot of smells that smell worse than burnt hair. So anyway, just be careful with that. Make sure you have your hair tied back. Next page. 21. In the laboratory, you should be cautious of D, all of those. All right, loose clothing, dangling jewelry, flammable clothing. Should be aware of all of those. 22. The following footwear is best in the laboratory. I would hope that you know the answer is C, closed shoes. When you spill something on the lab tabletop or whatever, inevitably, the way liquids work, they obviously flow. They're going to flow to the edge of the table onto the floor, and that's exactly where your feet are. So closed shoes is by far what you should be wearing when we have a lab-day schedule. 23. Horseplay or practical jokes in the laboratory are A, always against the rules. You'll see this in class, but back there, right to the right of the safety shower, I got a couple of posters on either side of it, of a little white cabinet there. On the right is the one where it says no horseplay in the lab. It's kind of funny. You got a horse basically doing everything back there that he shouldn't be doing when he's in lab. Goofing around, squirting a water bottle, not wearing his goggles. He's got his tail hanging over the Bunsen burner and it's caught on fire. Basically, that's kind of an extreme depiction of what can go wrong in a lab. But I can tell you this, in all seriousness, 9 times out of 10, when somebody gets hurt in the lab, it's because they're not paying attention to what they're doing. All right. And so I would just say lab time is serious time. It's not really time to be goofing around. So the correct answer to that was A. 24. To put out a fire in a person's hair or clothing, use A, a fire blanket. So let me look again. back there in the lab area, there we go, where the fire extinguisher is, right above that, and a big red canister is our fire blanket. And so it's made of a fire retardant chemical. Doesn't really smell all that good. But if by chance a person's clothing catches on fire, we're not spraying a fire extinguisher on a person. You don't do that. All right, that just makes a bad matter worse. We smother the flame. We deny it access to oxygen. That's the quickest way to put a fire out. And so we would just grab that blanket, roll you up in it. Okay. 25. All laboratory floors, aisles, and passageways should be kept clear of B, lab equipment, chemicals. Again, that's how they would get spilled or broken. 26. If a piece of equipment is not working properly, stop, turn it off, and tell the instructor. D, and I will take care of that. 27. Here's another acid question, but this is a little different. If an acid is splashed on your skin or clothing, then wash it once with. Some of you might have marked C, a weak base, because we just talked about earlier, well, we'll neutralize the effects of an acid with a base. And that's fine for most circumstances, but not on your skin, because not only can acids, based on what they are or how concentrated they are, not only are the acids themselves corrosive and caustic to your skin, but you pour a base on there to neutralize it, and that base may also have corrosive or caustic effects on your skin. So you don't want to have a double whammy there on your skin. The correct answer to 27 is D, plenty of water. In other words, you want to flush it with water, which will dilute or reduce the concentration of the acid very quickly and minimize the effects of it on the skin. So the correct answer to 27 was D. Okay. Next page, last page. When you finish working, 28, when you finish working with chemicals, biological specimens, or other lab substances, always B, wash your hands thoroughly with soap and water. All right. We have a sink back there at each lab table. I also have a sink in the very back of the lab area, which has hot water with it. I always have soap there, and so you are encouraged to do that before you leave the room. Of course, right now with COVID-19, one of the three big things you can do, there's three things that'll keep us all safe. Wear a mask, social distance, which here is tough, hence the real need for a mask. And then that third thing is washing your hands regularly with soap and water. That's a very important thing to do. And in lieu of that, use the hand sanitizer, which I'm going to have, as you recall, have you do when you walk in the room anyway. It wouldn't be a bad idea to do it on your way out either, especially if we've been in the lab. Okay, so 28 was B. The last 5 questions are true and false. 29, we've already talked about. Hot glass looks the same as cold. Yes, it does. True. Number 30, all chemicals in the lab are to be considered dangerous. Absolutely true. Some of you saying, wait a minute, water is a chemical. Is it dangerous? Well, let's see. If you get too much of it in your lungs, that'll kill you. If you get too much of it up your nose, that would be bad. If the water is heated to boiling and you spill it on you, yeah, that's pretty dangerous. If the water's in a frozen state, you get hit with a big chunk of it in the side of your head, yeah, that's probably going to cause some major damage. So is water dangerous? Well, commonly in a lab setting, no, but it certainly can be. So all chemicals are to be considered dangerous. In other words, treat them with care. 31, return all unused chemicals to their original container. That is false. Have an idea why? If you said, well, we might have been contaminated with something else, you'd be absolutely right. So we do not return unused chemicals to the original container. Don't do that. 32, work areas should be kept clean and tidy. Absolutely true. That helps to prevent accidents, all right, and spills. 33, it's okay to handle broken glass with your bare hands if you're careful. False. Do not do that. If we do, and we will, get any broken glass back there in the lab, you just tell me about it and I will clean it up myself. Right? I don't want any of you picking it up broken glass. So 33 is false. So that takes care of the safety study sheet. Again, there will be a quiz over that in Canvas in the same exact format. All right, same exact format. It's actually the same questions. All right, and that will be this coming Monday. That's what it's scheduled anyway, which would be August 17th. So I think we have covered everything that I was going to cover with you today. Again, your additional work for today was to work on the lab equipment study sheet, see what each piece of equipment looks like, what it's used for, because there'll be a quiz over that in Canvas on this coming Monday as well. We will go over each of those pieces of equipment individually tomorrow. So until then, this is Mr. Keister signing off for today. Everybody stay safe, and I'll catch you next time. So long, everybody.